Elliptic Curves, Volcanoes, Reality and Applications, Part 2, P. Clark, Frederick Saya, Abstract. Let m divided n be positive integers and let delta be the discriminant of an order in an imaginary quadratic field K. When delta K is less than minus 4, the first author determined the fiber of the morphism S0 m, n to x1 over the close point j delta corresponding to delta, and show that all fibers of the map S1 m, n to S0 m, n over j delta were connected. In the present work, we complement the work of CL22A by addressing the most difficult cases. Delta K belongs to -3, -4. These works provide all the information needed to compute, for each positive integer d, all subgroups of EF where F is a number field of degree d, and E over F is an elliptic curve with complex multiplication. 1. Introduction. 1.1 Main results. This paper is a direct continuation of CL22A, which determined the delta Cm locus on the modular curves x0 m, n over q. For delta, the discriminant of an order in an imaginary quadratic field K, different from q adjoining with -1, roots of -1, or q adjoining with square roots of -3. This work also gave a completely explicit description of the primitive residual fields of delta Cm close points, i.e., the residual fields Qp of delta Cm points P belongs to S0 m, n, for which there is no delta Cm points P prime, such that the Qp prime embeds into Qp as a proper subfield. Finally, the work also gave an inertness result for the fiber of S1 m, n to S0 m, n over delta Cm points on S0 m, n, which yields a complete description of the multiset of degrees of delta Cm close points on S1 m, n over Q. Using only the knowledge of the degrees of primitive residual fields of delta Cm points on S0 m, n yields the corresponding knowledge of degrees of primitive residual field of delta Cm points on S1 m, n, which is precisely what is needed in order to classify torsion subgroups of delta Cm elliptic curves over number fields of any fixed degree. In the present work, we treat the excluded fields Q adjoining with square root of -1 and Q adjoining with square root of -3. If delta is equal to F squared delta K, and delta K belongs to -3 or -4, then for all m divided n, we determine the delta Cm locus on S0 m, n over Q, and explicitly determine all primitive residual fields of delta Cm points on S0 m, n over Q. So I will give an interpretation here that S0 m, n is a delta Cm locus. This is there are two delta CM locus has how many points on locus? H delta, class number, is the number of points of delta CM locus, and we view it as a pair of points from the original point delta k, which is -4, for example, to delta CM locus. So this is a pathway that is from P to P prime. This is the locus. There are H delta. Number of the points are H delta. And the original point has 1 point, which is delta CM is equal to -4. And the delta is equal to F squared times -4. The locus are H delta. And the S0 m comma n means a pair, multiple pairs of P to P prime. Okay. Finally, we show that the fiber of S1 m comma n to S0 m comma m over delta CM points are connected. Taking together the works and the present work give a complete description of torsion subgroups of CN elliptic curves over number field. In particular, we get an algorithm that takes as input a positive integer d and outputs the complete finite list of group isomorphic to EF tors, where F is a number field of degree d and E over F is a CN elliptic curve, conditionally on knowing the finite list of imaginary quadratic order of class number, properly dividing d with current knowledge about class numbers. This allows us to enumerate CM torsions in number field degree d less or equal to 200. If we are willing to assume the generalized Riemann hypothesis, then we can enumerate CM torsion in number field degree d less than or equal to 18104. This enumeration will appear in the future work. 1.2 Review of delta k is less than -4 case. Let us outline the proof of the computation of the fiber of S0 m comma n to S1 over the closed delta CM point J delta on S1 given in CL22A, so that we can see what must be modified to treat the case delta k belongs to -3, -4. So give commonly here. There are many J prime. These form a locus of delta, J delta. So a closed point, J delta, means a closed orbit of Gawa orbit of J delta. The size is H delta, and all of these points form a J delta. So we can see that this is from J delta k to J delta. So S0 m comma n can be viewed as a pair J delta k comma J delta.